Hello, good afternoon, everyone. And it's 1 o'clock. I guess we can start our training today. Jessica is out today, so I will lead today's training and for this week, week 5. And before we start the training, Jesse, do you have anything to say before we start it? No, I didn't hear anything. How about anything from TA?
Yeah, we can hear you.
Okay, great. All right, and we can start. Let me share my screen. RStudio. So maybe I can turn off my camera when I do the training. Were you able to see my screen well? Do I need to zoom in or it looks okay?
It looks like you need to zoom out a little bit. Sorry, it looks way big.
Okay.
Yeah, we
Zoom
can
out.
only see the console.
Okay. I can zoom out a little bit. Okay. It's better now? And yeah, okay. Usually what I do is, okay, create a new file and then save it in my, so I have a folder, I have a project folder where there's multiple subfolders. And I usually save it in the, oh, it's very, hi Jesse, can we mute everyone?
Yes, I will mute everybody. Thanks.
Oh, okay, thanks. Okay, where's my screen? Okay.
Min, will you unmute yourself? Looks like I accidentally muted you and now I can't unmute you.
Oh, yeah, I think that's the case. Okay, can you hear me now?
Yep, you're good.
Okay, great. Okay, we can start right now. So for this week, we're gonna cover functions. And we touch base about some basics of how to call functions in the first week. And today we're gonna learn more about functions, maybe customized function where you can create functions on your own. So I feel that is very useful as well. And so if possible, maybe you can open the training materials on the GitHub site, and we can start from there. And the first session about today's training is about some of the built-in functions for numbers. And I would say almost everything R is done through calling functions, either functions that already exist in different packages or the functions that you are going to build it by yourself. And so I will introduce some of the numeric functions. And it's, as you see from the training materials, we don't have any numbers to play with, but that's okay. And usually at the beginning, because today we're gonna work with the air quality data frame, so usually it will. I always load the libraries at the beginning of my code, so you can do the same. Okay, library tidyverse. And another is janitor. That is, I like it very much. And library lubricate. Okay, so you can load these 3 libraries and select them and then Control Enter and run it. Okay, so this is a way to load the libraries. Or you can write notes, right? Load libraries like that. Okay. So all is good. And the next one is, if you look at the training materials, right, we have some numeric, some functions where you can deal with numbers. So the first one is absolute value. So let's see. We can do sequence, maybe 0.05 to 1, like, okay. So we can create some numbers for practice, okay, like X. So you can see that, right? We create numbers from negative 0.5 to 1 with the sequence of 0.25, okay, just for practice purpose, okay. And the first function we want to practice is absolute, right? ABS, okay, ABS X. I call this function after you type this, and you can do, you run this one, right? You either you click this run button or you just do Control Enter for Windows, right? Now you can see that all the negative values becomes a positive, right? That's how absolute ABS function did for us, right? And so this one is to, okay, if you like to take notes, right? We can write on create some numbers. And this one is to get absolute values. Okay, this is for ABS. And since I rarely use this function, okay, another is the root square, right? Square root is QRTX, okay? Let's see what this one will have. So if you call this one, okay, SQRTX, right? Because, okay, we do got warning message, right? So we have 2 NAs for the first values. If you still remember X, right? Okay, if you don't remember, we can take a look at, right? -5, negative 0.25, right? If it's negative values, it doesn't work, right? To take the square root of negative value. That's why we get warnings and the output are NAs. Okay, I think I use this one the most. Okay, let's take a note. Put a note here. Square root, to get square root, and I use this a lot. Round. Okay, round means you round the input to certain decimal digits, right? And for example, for this case, you can put digits equals to, for example, let's have 1 here, right? And okay, so what we have here is we previously has 2 digits, right? And now we rounded it to like 1 digits. So sometimes you may find this round function quite useful a lot, especially for my case after I do like modeling stuff and all the outputs are very long digits, right? And I want to make a table. I only want to show maybe 2 digits. In that case, I always use this round function. Okay, this is a round x to 1 decimal digit. Okay, so this is a round, and there are logarithm. There's 2 log. I have 2 functions like log x. If you can see that, if you type that log x, okay, again, there are some missing values and like infinity values. I mean, it will calculate what it is able to calculate. Okay. So, and this is a natural log based on e, and there is log 10x. Okay, this is a logarithm based on 10. Okay, and it's the same thing, right? So it will do what you could do And this is for natural log E. Okay. And the other thing will be the common log 10. Okay. And the last one is the exponential exp. I mean, it's the same function that used in Excel. So this is quite straightforward. Okay, so it will calculate the exponential of x, xp of x. All right, and those are for, okay, if you want to take notes, this is the session 1.1 and functions for numbers. Okay, and we have a session 1.2. Yeah, statistic functions. And for this session, we're gonna know about some of the commonly used statistic functions. It might be good to summarize the data, right? Calculate the mean, median value, and also sometimes maybe maximum and minimum. So at this moment, you probably, when you want to summarize your data, so probably you want to use these functions, for example. Again, x. Okay, for our case, we don't have any missing value, right? So it's not necessary to specify, okay, remove missing equals to true, right? The default of that argument is false. So we can simply call mean parentheses x, right? That will be calculate mean value of a vector, okay? This is for me and median x. So it's the same thing, right? It calculated the median or it is a 50% percentile, okay? And this is for median value. And I have some other like SD standard deviation and quantile where you calculate like a 25 percentile or 70% percentile, where that is very commonly when you make the box plot, right? Which will show the different quantile. Okay, SDX. And okay, this is the standard deviation. And okay, and what else do we have? We have quantile. Okay, X. So this where this is the quantile function where you can specify what is the probability, right? For example, if we do 0.5, right? We expect it to have the same value as our median, right? Okay, see that is a 50% is 0.25, right? And so this is 50% quantile. And of course you can calculate like 0.75 quantile as well. So just to change the second argument, then you should be able to calculate the quantile, different quantiles. And the next one is range. Okay, range basically gives us what is the range of this data set, right? Range, and it's a good statistic metrics to describe the distribution, right, of your data. That what is the maximum and the minimum, right? It's minus 0.5 to 1, okay? You can see, right, on this environmental panel, right? Its minimum is negative 0.5 and maximum is 1. And okay, sometimes it's always after you write your script, right, try to save it. Okay, click it and it will saved. Okay, we did the range. Okay, let's rearrange this a little bit. Okay, this is 75 quantile, and range is basically give the minimum and maximum of x. Okay. Of course, we can also call min function to get the minimum value, and also max function to get the maximum value. So they matches, right? And I mean, the function itself tells what's the purpose. So maybe it's okay if I skip to take a note of this. Okay, the last one is sum. Okay, summation, right? You basically calculate end up every element of this vector x. So that is 1.75. Then get the summation of x. All right. So those are some of the selected built-in functions. And next, we're gonna do the main piece of our for today's training. Okay, that is write customize the functions, right? Write functions. And so one of the good thing of R is we can write our own functions and use it again and again. So in general, if you try to do copy and paste, in my case, I usually, if I do copy and paste like more than 2 times, I think, okay, that's a good sign. I should write a function, right? And to simplify my code. And we already talked about the functions early in week 1. So today we're gonna learn about how to write functions on our own. Okay, functions are defined using the function function. Okay, so basically this function, parenthesis, is the one you want to call in order to write your own function. Okay, the basic structure of a write a function is first we always have a function name, right? You for example, you're gonna give a function name and then assign the functions you're gonna write, right, to this function name that will create a function object in R, right? Then you can call it again and again, just like we call like a sum or max or what other built-in function. Okay, so the structure, so inside of this function, right, we're gonna provide the arguments. For example, what is the arguments? For example, here, right, a max function. This x is called the first argument, right? Of course, we can have more than one argument. For example, round case, right? Digits. Digits is the second argument. Sometimes you can have more than 2, right? You can have as many as you could. So those are the arguments. They were separated by a comma, right? And then after parentheses of this function, right? We type this curly bracket, okay? And inside of this curly bracket, we're gonna provide the body of this function, right? Are you going to, for example, you're gonna do some conversion, or you're gonna do data manipulation or data processing. Okay, you can do whatever inside of this function body, right? This is the body of a function. And so this is a very basic, right? Just 3 lines, right? And then you should be able to write your own function. We will try to do a simple example, right? So, I mean, I think it's always good to learn from examples. Okay, we can just, I can comment this out. Okay, and then we can start to write our own function. Okay, so this example is a convert temperature from Fahrenheit to Celsius. So first we give a function name, right? Give a function name like a F to C, right? Whatever. Or usually I always start with a verb when for my own project. So maybe convert temperature. Okay. And so of course you can name it different, right? You can use the training material F to C, right? It doesn't matter. So function, okay. So we have an object convert of temperature, and then assigned we assign function, right, to that, and then argument, right? We want to have a Fahrenheit, right, temperature F as our argument, and curly parenthesis, okay. After this curly parenthesis, we're gonna do, okay, temperature C, okay. The formula of conversion, right? We have it like a temperature Fahrenheit minus 32 degree and times 5 and divide by 9. Okay, that is a formula where we can convert temperature from Fahrenheit to Celsius. Of course, sometimes you may find, okay, you want to convert unit conversion, right? For it can be used, it can be good to write a function to convert units. Okay, this is a function. Okay, once we done writing the function, okay, then we can run this one. Okay, you can do Control C, Control Enter, or click this Run button. After click that one on the in this environment panel, and you will see functions pop up, right? And actually, it's convert underscore temperature. It has, there is a function available that you can use. Okay, and okay, let me save this again. Okay. So next is we're gonna try to use this function. Okay. One thing we can do is, okay, well, I forgot to mention about it. So after you did the temperature unit conversion, right? You want to type return temperature C, right? I would think it's a good habit to do this. Sometimes I don't do that because in R, the returned value of a function is always the last expression that has been evaluated or you calculated. In this case, right, the last expression is this formula, right? So even we don't assign this a formula to temperature temp C, and after we call this convert temperature, it will return the calculation. Or even and this is one thing, or if we don't call return, it will also return temperature C because it always returns the last one. But and at the beginning, at the learning stage, it's always good to learn everything. So we can Control Enter. Now we're gonna practice. For example, today's temperature. Okay, today's temperature is 68 on my computer. Okay, we can call this function. Okay, convert temperature and 68. Okay, and Control Enter. Right. If you type that, then convert it to 20 degree C. Right. That is okay. It seems our function works. Right. And when I write a function, after I write a brand new function, I always try to use some simple numbers to test if it works or not. So I think that is a good strategy to test the function, the first function we just write. Okay. And I mentioned about, okay, you can, if you don't call return in your function, right? For example, if I comment this out, I Control C, and Okay, it didn't show anything, right? And but if you print it, it will print the 20, right? So that's something I want to just wants to mention about. So I always I mean it's always good to have that return after you at the end of the function to tell the function which parameter you want to return. Okay, next we're gonna apply this function, convert temperature to our air quality data frame. Okay, let's take a look at our air quality data frame first. View air quality. Okay, this is a data frame. We already see it many times. Okay, there is a column that called the temperature, right? It's if you look at that, that is the unit should be Fahrenheit, right? We're gonna create a new column to that to this air quality data frame. Okay, let's call. We can give it a new name like AQ air quality. Okay, if you still remember pipe, right? This is a Control Shift M to that's a shortcut to type pipe. Okay, and we are going to create a new column. So we're gonna use mutate, right? Mutate. Okay, temperature C. That's the new column name equals, okay, convert temperature. That's a function we just created, right? We're gonna convert, okay, it has only one argument, that is the temperature, right? And let's Control Enter. To run this script, now we have a AQ data frame. Okay, in this data frame, right, we have a temperature C, right? You look at here, okay? And maybe sometimes you say, okay, can I round it a little bit to make this a little bit prettier? Okay, you can do that. Round the temperature C, and maybe 2. Okay, so let's see how the AQ looks like. Okay, now it looks better. So we don't have too many digits. And this is where why I say I use this round function a lot. All right. Do you have any questions so far? I believe TAs are working on this, but if you want to have anything you want to talk about on the Q&A, just let me know.
We're good in
Okay.
the chat, Min.
Okay,
Just so
thank
you
you,
know.
Liz. Okay,
Mhm.
sounds good. Okay, we can continue. Next one is argument matching. So this is, let me write some notes. Okay, it's always good to take notes, right? This one is create a function to convert Fahrenheit to degree C. And this is where, and you can also take notes here. For example, add a new column for temperature degree C. Okay. And then round C with 2 digits, right? You can add that. Okay, this is for how to write functions. And next, we're gonna talk about argument matching. Okay, 2.1 argument matching. So in R, and when you call function, right, we already know about there you can has multiple arguments inside of this function. And in our training materials, we have a example, right, to calculate to some simple math. And so if you have more than one arguments, right? And we can match the arguments either by position or by name. So position matches just means the first value will match the first arguments, while the second value you put it inside of that function will match to the second argument. That is how we do position arguments. We did it a lot. For example, here, right? We didn't provide the argument's name, but in this case, right, digit round case, right, we do provide the argument's name. So that is another way you can do this argument match. So you provide the name of that argument. And we're gonna take a look at it for both case. And for the simple example, we let's do, okay, let's take a note first. Okay, this is create a simple function. Okay, like example function obtain math. This is the main purpose of doing this is trying to show about this argument match. Again, function, right? We call function a function name and put the arguments for this case A and B, right? And followed by this curly bracket. And we here is A times A plus B, okay? This is a very simple function, right? Once you run it, you see you have a new functions being available to use. Okay, let's save this. Yeah. So we're gonna do arguments matched by name. Okay, what you can do is obtain math. So by name is you assign a value to A, right? Then assign a value to B. That is called argument matched by name. And if we control enter, so it gives basically A is 1 times 1 plus 2, that gives us 3, right? So that's correct. That is exactly what we want to do. And another thing is by position, right? You can call math by position. Okay, 1, 2. If you do this case, right, 1 will be assigned to A. Okay, 2 will be the value for B. Okay, we should expect the exactly same output here. Yeah, and obtain if you want to see the difference. Okay, if you try to 2 and 1, okay, definitely it's gonna give different values, right? Because right now A takes 2 and B takes 1. So that's this is very simple, but I feel, yeah, it's good to know about this argument match. And next one is arguments with a default value. And sometimes, for example, for this case, right, here we have 2 arguments here, but if we only provide 1 argument, okay, in this to our obtain math function, and we see what's gonna happen. If you type it, it will say, okay, there's an error and argument B is missing and with no default. Okay, with no default, what happens if we have a default, right? So let's give it a try. So in this case, we need to revise our previous function a little bit, okay? You don't have to type it because you already did it. So this case, we can give B a value, right? Whatever value we can give it to, okay? So if we give B equals to 2, that means that B takes the default value of 2, unless when we call the function, change B to a different value. So B will always be equals 2 and in this formula, okay? And since it has a default value, now we can obtain math 1, okay? So, oh, I forgot to call this one. Yeah, to run this function, okay, obtain math. Okay. Now we only have we just need one function. We just give one argument, right? Then it should be able to use that default b value to calculate the mass here. Okay. This one is an example default argument. This one is with default. Okay, default is basically you provide a value when you create this function, right? Just like, for example, if you look at this many times, we calculate the mean function, right? The average, the mean value. And if you do question mark and the function name, and in the console, right, it will provide the explanation here. Okay, look at this. So there are some, for example, there are some arguments right here. For many times I use it. I use this a lot. Na.remove if you want to remove this missing value or not, right? We can change this default from false to true, right? So we can calculate the mean value without missing values. All right. So those are about the arguments with a default value. Okay. Next. After we were able to create our own function, right? Next is apply functions, right? And there are two ways you can apply this function. And what we are showing right now is in your script, your working script, you create these functions and you run it and you use it, right? So we can use this air quality data frame to practice how to apply functions, right? This is 2.3, apply functions. Okay, and I think in last week we learned about the case when, right? Where we like if else and case when, if you have multiple conditions you want to evaluate, maybe you probably want to use a case when instead of doing that nested if else loop. So here we can, maybe this is a way we can create a simple function to convert month to season, right? There's no, I mean, I'm not sure there is, but assume there's no package provide that function to you, and you, many case you want to convert month to season, right? To understand the seasonal trend of your data. Okay, at that moment you probably want to create a function where you can convert months to season, right? So let's create this. Okay, let's write a function to convert a month to a season. Okay, and I always give the function name. I mean, I always create the function name with a starting with a verb. So, but you can have your own rule how you want to name the function. Okay, obtain season, or you can do convert month to season. Yeah, obtain season. Again, this is after this assignment operator followed by function, right? And parentheses, then we will provide the arguments inside. Okay, you can do month or you can give it a different name. And after that, it will be the body of our function. So if you still remember how to write a case when, so case when underscore when, case underscore when, then parentheses, okay, month. If this, your month is any of, in any of this vector, right? So winter is December, January, and February, right? If the month is in any of this, is any of this month, right? With till the winter, okay? Then you will return winter, right? Return winter, okay? And then this is separated by comma. this is one argument. And then if your month is in it's March, April, and May till it is spring. Month percent in percent, that means it's in either of this value. Okay, June, July, August. Okay, that will be summer. Okay, the last one. Percent in percent. Okay, if it's September, October, or November, we would have got fall. All right. So this is a function we just created to convert month to season. Okay. Now we Control Enter to run the script, and again we can take a look. Right, we have a obtain season function here already. All right, and okay, and we can give it a try, right? Always it's good to use some simple number to test if the function you just wrote works or not. So now it's August, right? We can provide 8. And then, so it's a summer, right? August is summer, that means it makes sense. So our function works. And with that, we can, let's see, we have a AQ, we have our AQ air quality data frame, right? There's one column called month. Maybe we can create a new column like a season to convert all this, to create a new column to show which season for each month, for each row of this data. Okay, to do that, it's very simple. We have AQ already, and we don't need to touch the original air quality data. And mutate, right? Mutate is a function to create a new column. Okay, we can have a season, that is the column name, equals, okay. We are going to call the function we just created, right? Obtain season and month, right? Month. Let's see how that will work. Okay, Control Enter. And let's take a look. Okay, here's the season, right? We have a new column. For example, May, is correspond to spring. Okay, that makes sense, right? And June is for summer. All right, so that's how we apply functions we just created to create a new column of our existing data frame. Of course, this is where we use it functions inside of the working a script, right? And there's another way I feel that is very useful as well. So you can also save your functions in a different script and then call that script. You source that script at the beginning of your file, and then you can use it again and again, right? So how can we do that? Basically, we save it in a different script, right? So click this new file, yeah, R script, okay. And then what you can do is you have this obtain season, right? You just copy and paste it to this new script, right? Once you've done that and click this save button, right? You have a new file and save it. I always save, for my case, I always save my script in this script folder. You can save it to a different place, but just remember where you can find it when you need to call it. My functions. Okay, now we save these functions, this file to, okay, under the script folder, okay, my functions. All right. So once I do that, I can call this. I can use this. I mean, I have a little bit one more step to do in order to call a function in a different file. So usually I do it at the very beginning. If I have a big project, I usually have like maybe 10 functions saved in this kind of my functions file, and I always try to call this script. We use a source function, right? We source it at the beginning. So use a source to read the R script. For example, you want to do, then you put the file name and the path of my function script. Okay, for my case, it's under script and functions that are, okay. And once you do that, okay, you source it. Okay, here we couldn't really see anything because we have this obtain season function in our script already. So to test how it works, what you can do is clear all objects from the workplace. Okay, yeah, clear. So your environment is empty, and we can rerun this. Yeah, it's very easy. Oh, okay. I think I would take notes here. Okay, and this is to read R script. Maybe you can more specify, right? Made functions.R script, right? You try to read it at the beginning. Okay, so now there's nothing. What we can do is, okay, we can select this lines and Control Enter. Okay, after we call the source function with this script, in our environmental and history panel, you will see functions obtain seasons available to be used. Okay, you can click that one. If you click this function, it will bring up the script file, right, where we save this function. If you see obtain function here, that means it's ready to be used. Okay, we can give it a try this time. Because this is AQ, and let's change it to air quality air because there's no AQ here, so I don't want to redefine it. I can just use air quality, right? Okay. All right. See, now if we look at this AQ again, okay, it created a new column called the season, right? That's how it works. So this example just trying to show to you, okay, if you have multiple functions, usually if I have more than 3 functions, write it inside of this my main work script, I will try to save it in a different file. So my main script will looks, I mean, it's a little bit clean and easy to read and to follow. And so this is one of the tips I would like to share with you. And do you have any questions from the Q&A panel from the trainees so far? Anybody has any problems so far? Or if you want to clarify anything? No?
There
All
are
right.
no questions in the chat, Min.
Oh, okay. Hopefully no one falling asleep.
No, I don't think that's the case.
Okay, I'm happy to hear
We are
that.
intently following you, Min. This is really good. Thank you.
Oh, yeah, that's a very nice and kind feedback. Yeah, I used to let the volunteer to drive the live demo because I think that's a good way to keep you awake instead of sleeping. But I mean, based on the feedback, the people the instructors will share the the screen to drive the demo. I mean, I'm totally fine with that. That's why I'm doing it like this way. So we have about 10 minutes left. And do you guys think it will be a good idea? We can talk about this exercise. I mean, we can do that. So the exercise is write a function using year, month, day to obtain weekday and weekend. Okay. For example, write this obtain weekend function, right? With 3 arguments, year, month, and a day, right? In order to do that. So this involves with a date, right? If involves with date, so you always want to call this package, right? Lubridate. So hopefully you already loaded. And when I write a function, I usually do not write straightforward. I mean, to go this part, I always start with try to build it piece by piece. And once I'm testing with some example, then I convert it to a function. So this is maybe I can show you how I did this. For example, in this case, right, we are using year, month, day. For example, we can use today as an example. And so since it's gonna obtain the weekday and weekend, right? We learned about W day is a function we want to use, right? In order to call if it is what is the specific week day of a week. So we want to use W day to do that. Once we finish that part, we have we kind of do if else, right? If it is Saturday and Sunday, we name it as weekend. If it is otherwise, right, else it will be weekday, right? You can think about what are the steps gonna involved. And another thing is, if you just have year, month, day, right? We need a date, a data type, right? In order to work with the Lubridate, the package, right? That's dealing with date and time. So what are we gonna do first is make date, right? Make date. Okay, make date. So we have year. What we can do it like this. Okay, year, for example, 2024, a month is page, and day is today. Okay, 20th, right? Then, okay, once you define these variables, and then you can create a date, right? And to see how that will work. Okay, make date, it will create this, we create a date, right? It's today. And then after that, we're gonna do W day, right? W day will convert a date to day of a week, right? Okay, so then if we have a date and then okay, so this is a pipe, right? Pipe, so after the pipe, right, the function will always take the previous one as its first argument. So W day, the first argument should be a date, right? We can skip it because it always take the previous value as the first argument here. So we have this, it's Tuesday today, right? So it's Tuesday, that's perfect. Okay, so it works, right? And then it's assign it, right? And it's for like a taste. This is for testing, okay? Testing, okay. And okay, then we do if else, right? If else, if taste is, if it's a Sunday or Saturday, right? If it's a Sunday or Saturday, and then we call this as a weekend. Otherwise, else it's, if it's not Sunday or Saturday, it will be weekday. Okay. Okay, so today is Tuesday, and we expect it is weekday. Okay, so that means it works. So usually once I use some simple data to test it my functions, then I will start to create my function, right? Obtain weekend, weekday, whatever. So function, right? We always, if you create your own function, right? It's a function. We have 3 arguments: year, month, and day. Okay, followed by this curly parenthesis, curly bracket. Okay. Okay. You can do test. Let's see, we almost run out of time. So this time I will have this shortcut. I will do copy and paste. Okay. So in this one, okay, inside of this function, right? Since our argument's name is the same as our previous variable names, I even don't need to change anything. I can directly use this copy and paste. And I don't need to call return it because it's gonna return the value of this if else function. And okay, obtain weekend. Okay, we run it. Okay, let's see, do we have this function here? Okay, we have a function here, right? Look, this is obtain weekend. Okay, after you've done that, you can test it, right? We can always test it using some simple numbers. We can do 2024, 8. Let's test tomorrow, 21. Okay. Okay, tomorrow is, it's still weekday, right? It seems correct. Okay, this is a exercise. What else does it say? Apply this function on air quality data set. Okay, I don't think I need to do that. It's same mechanism. Once you were able to obtain weekend, right? Then what you're gonna do is similar like this, mutate, right? Mutate weekday and call this function and apply year, month, day, right? This case, if you look at our air quality data set, view air quality. Okay, this is the air quality data set, right? We do have a month and day. That means year, we need a year, right? You can create a column called year, right? You can use any year, just for example, as a practice, right? Once you have this year column here, and then it's the same thing, right? You commutate, right? Obtain weekend and put a year, month, day there, and run it. You should be able to create a column similar like we create for season. It will show you which one is weekday, which one is weekend. This one, I feel sometimes it can be very useful, especially we want to investigate some trend like a weekday and weekend trend for certain pollutant concentrations. Do you see more higher level of certain pollutants during weekday compared to weekend? I think that's most of it is true for traffic related air pollutants. Yeah, maybe that's a potential use of this kind of customized functions. Yeah, I think that's all I have for today. And we almost run an hour, and let's see if we have any questions, and I will be very happy to help.
Can I see the exercise in full mean one more time? The exercise. I am missing some steps.
You mean this function? Obtain weekend function? Yeah, sure.
Yeah, okay, great. Thank you.
Yeah, you're welcome. Yeah, I think this is like 70% done with this exercise. You just left is you can apply it to the air quality data set. Then you're good to go. Do we have any other questions?
Yeah. There's no questions in the chat, Min, but there was a comment after our last break. Tyler said we're awake with a smiley face in the chat. So that was nice.
Yeah.
But no questions.
Okay, great. Yeah, sounds good. I think we can ramp it up and we can end here. And I will talk with you learn with you together on Thursday. Yeah. So have a nice Tuesday, everyone. Thank you. Okay.
Thank you, Min.
Yeah, sure.
Thank you
Thank you, Liz.
so
Yeah.
very much. Thank
Yeah,
you.
you're very welcome. Yeah. Bye bye, everyone.